students, and welcome to our lesson about equations as functions and all about graphing functions by table. So first we're going to do our do now, which will be about understanding others, and we'll have a quote from Dr. Stephen Covey. Our objective today will be to learn how equations can be functions and how we can graph functions. So our essential question is, what distinguishes independent and dependent variables, and how can I graph functions? Our assignment today will be to watch the video on equations as functions, complete the 2 assigned pages and the graphic organizer. We'll complete the graphic organizer as our exit ticket today. And our homework will be homework 3, 1 page, equations as functions. Important notes: if you have been sent an assignment spreadsheet from me, please make sure that you complete the unfinished work. Homework, even though I don't collect it each day, should be done on the day it is assigned, and that's so that you don't forget and you get that important practice at the point of when we learn the new skill. I have for you today a little quote by Maya Angelou, who was a United States Poet Laureate, a wonderful woman, a wonderful poet, a great writer, and she led an extraordinary life, and she also had a lot of adversity in her life, and she, learned a lot that kind of gave her a sort of wisdom that she chose to bestow on all of us. And one of the things she said was to be present in all things and thankful for all things. And if you have the opportunity to learn more about Maya Angelou or to read a biography about her, I would encourage you to do that. Our do now prompt is this quote from Dr. Stephen Covey, who said, "Seek first to understand, then be understood." That actually is a little bit biblical, comes out of the Beatitudes in the Bible. But anyway, Dr. Stephen Covey was a great author who wrote a book called The 7 Habits of Highly Effective People, and his son, Sean Covey, took that book and converted it and directed it towards teens, and he wrote a book called The 7 Habits of Highly Effective Teens. And wonderful book. I would encourage you to not only read it, but apply it to your life. So I want you to think about what it is to seek first, to understand before you want to be understood. And please respond to that in your Do Now journal, just with a sentence or two. So our exit ticket will be a graphic organizer, so that will come after our lesson today. So let's get started with today's topic. So for today, let me get it back. For today, our topic is equations as functions. Okay, and let's start out with some guided notes. Functions can be represented by an equation, or we can call that equation a kind of rule, and you'll see how that works in a few minutes. The equation will generate ordered pairs. And it will do that by taking an input that results in a certain output or generates a certain output. And the graph of an equation is the set of all of its ordered pairs, which forms a line or a curve. Now, lots of times when we learn about functions, math teachers like to analogize a function to a machine where you have one distinct x input that produces one distinct y output. We call the x value the independent variable. because it is the variable that you select. The y value, however, is called the dependent variable because its value depends on the value of x. So if you put x in, you'll get y. So that's one way to remember the function. So let's look at this mathematically as well as graphically. So we're asked to graph some functions by table. And basically what we're doing is we're substituting these x values, and our output will be this y value. So we're going to substitute for x. I encourage you, please always use parentheses. We will substitute -5, -4, -2, and 0. And I've taken those values and I've go ahead and I've started that. Sorry about the email. Let me see if I can turn that off there so we don't hear it. Okay, so I've substituted those values. Let's go back again. We have y equals x plus 4 right here. I've substituted these x values in the xy table. And then I've evaluated the function for these specific x values that have already been provided to us. So we've been provided with a -5, a -4, a -2, and a 0. And it's just evaluating an expression. So if we have x plus 4 and x is -5, then we evaluate -5 plus 4 is -1. So when x is -5, y is -1, and that's how we get our set of ordered pairs. When x is -4, y is 0, and that's a second set of ordered pairs. When y is -2, x is -2, y is +2, there's our third set of ordered pairs. And when x is 0, y is 4. And this is our last set of ordered pairs. So let's transfer this information to our solution. So we now have, let's change our color so we can see it. When x is -5, y is -1. When x is -4, y is 0. When x is -2, y is 2. And when x is 0, y is 4. Now, we have these ordered pairs. Think of them like this, the way we write ordered pairs, -5, -1. Okay, we have 4 sets of ordered pairs. Now we need to graph them. So -5, -1, 1, 2, 3, 4, 5, right there. -4, 0, -2, 2, and 0, 4. And see if I can draw a straight line. There is our graph. Let me see if I can make it a little bit darker. And that's the graph of y equals x plus 4. So number 2, we have a new equation, y equals 3/4 x minus 2, and we're given the values -4, 0, 4, and 8. So we're going to put parentheses around x, always use parentheses, and we will continue to evaluate. So number 2, we have y equals 3/4 x minus 2, and we're substituting when x is -4, y is -5, and here's our first ordered pair, -4, -5. When x is 0, y is -2, 0, -2 is our next ordered pair. When x is 4, y is 1, 4, 1 is our third ordered pair. When y is 8, when x is 8, y is 4, 8, 4 is our fourth ordered pair. So let's go ahead and insert those. So we have a -5, -2, 1, and 4. And these are our ordered pairs. So -4, -5, 1, 2, 3, 4. Yep, right there. 0, -2, 4, 1, and 8, 4, which is off the graph. We could imagine it would be 1, 2, 3, 4, 5, 6, 7, 8, 4, somewhere around there. And let's connect that with the straightest line we can get here. Putting arrows on the end, those are important. And that is the function of y equals 3/4 x minus 2. Number 3, y equals 3x. And we're given the x values of -2, -1, 0, 1. So let's move on to number 3. So here's our function, y equals 3x. When x is -2, y is -6. And that's our first set of ordered pairs. When y is -1, x is -3, so -1, -3 is our next set of ordered pairs. When x is 0, y is also 0, so the origin 0, 0 is part of our graph. And when x is 1, y is 3, so the ordered pair 1, 3 will be part of our solution set. So let's fill in our chart, our table, -6, -3, 0, 3, and let's graph those. So -2, -6, 1, 2, 3, 4, 5, 6, -1, -3, 0, 0, and 1, 3. And let's connect those with a smooth line. Now, some of you, as we get into this part of algebra, will be making beautiful graphs. I'm sure the very artistic ones among you. I struggle a bit with the straight lines, so I'm looking forward to seeing your beautiful graphs. And if you work carefully, this is the opportunity to use all those gel pens and pretty things that you have. So let's look at number 4. Y equals 1 -3/2 x plus 2. Remember, encase x in parentheses for your substitution. So number 4. Sorry about that. Get back to my number 4. Okay, so y equals -3/2 x plus 2. And when x is -2, y is 5. When x is 0, y is 2. And there's our ordered pair. When x is 2, y is -1. And when x is 4, y is -4. So let's transfer those numbers onto our paper. So -2, 5, 0, 2, 2, -1, 4, -4. Okay, -2, 5, 1, 2, 3, 4, 5, 0, 2. Oops, I just made a mistake. Okay, let's try to get that again. I did -5, it's +5. -2, +1, 2, 3, 4, 5. That's better. 0, 2, 2, -1, and 4, -4. 1, 2, 3, 4, 1, 2, 3, 4. And let me connect that with as smooth a line as I possibly can. Putting arrows at each end. And that, my friends, is the graph of y equals -3/2 x plus 2. Let's do 2 more. Here, number 5, we have the graph of y equals negative x plus 1, and we are given the domain of negative 3, negative 1, 0, and 4. So let's evaluate those. So y equals negative x plus 1. Okay, negative x plus 1, here we are. Okay, so when y is negative 3, when x is negative 3, y is 4, and our ordered pair is negative 3, 4. When x is negative 1, y is 2 for an ordered pair of negative 1, 2. When x is 0, y is 1 for an ordered pair of 0, 1. And when x is 4, y is 3, an ordered pair is 4, negative 3. So let's transfer those onto our paper. So we have negative 3, 4, negative 1, 2, 0, 1, 4, negative 3. Let's plot our points. So negative 3, positive 4, negative 1, positive 2, 0, 1, and 4, negative 3. I don't think I went down enough. Let's plot that point again. 1, 2, 3, 4, 1, 2, 3. That's better. Okay, and let's connect that with a smooth line. And that is the graph of y equals negative x plus 1. And we'll be learning a lot very soon about negative and positive slope. But meanwhile, our next problem, number 6, we have y equals 1 minus 1/3 x. Please use parentheses when you make your substitutions, and x, we will evaluate for x values of negative 3, 0, 3, and 6. So here we are, y equals 1 minus 1/3 x. You take a look at those values again. Okay, 1 minus 1/3 x. So when x is negative 3, y is 2. Ordered pairs are negative 3, 2. When x is 0, y is 1. Our ordered pair is 0, 1. When x is 3, y is 0, and our ordered pair is 3, 0. And when x is 6, y is negative 1 for an ordered pair of 6, negative 1. So let's go ahead and complete our chart. So negative 3, 2, 0, 1, 3, 0, 6, negative 1. And let's plot those points. Negative 3, 2, 0, 1, 3, 0, and 6, negative 1. And let's go ahead and connect those with a smooth line. And that is the graph of y equals 1 minus 1/3 x. So those are substitutions for finding the value of a function when given x values. But now we are looking at it from a slightly different standpoint. In this case here, we are, get a highlighter here. We are given the function and the domain, but we are asked to find the range of values. So our function is y equals x minus 5. And we are given the domain 4, 6, and 8. So when I make substitutions, so let's put parentheses, I substituted 4, 6, and 8 minus 5 as in the original function. Now this time I'm making a table of values, And I've input my x values that are given. These x values that we've been given, we've inputted right here. So now let's evaluate. When x is 4, what does y equal? Well, y equals -1. When x is 6, y equals 1. And when x is 8, y equals 3. So now the range of our function is the y values. So the y values are the range, and we put them in order from least to greatest, -1, 1, and 3. And that was what we were asked to do, find the range of the function. Same thing here, we're substituting for x in number 8, y equals 3x plus 1. We're given the domain of -1, 0, 1, and 4, which I've substituted in the equation. As I evaluate these, I make a table of values, and I find that when x equals -1, y equals -2. When x equals 0, y equals 1. When x equals 1, y equals 4. And when x equals 4, y equals 13. So this is the range. Let me get the highlighter here. So the range is the y values. So when I write the range, I'm going to write from least to greatest, -2, 1, 4, and 13. Moving on to number 9. Our equation or our function y equals 4 minus x. We are given a domain of -2, 3, and 5. When we evaluate the function at those values, when x equals -2, y equals 6. When x equals 3, y equals 1. And when x equals 5, y equals -1. So this is our range, and we're going to list those in order from least to greatest, and that's the range of this function. Remember, they gave us the domain. We were asked to find the range. Number 10, we are given y equals 3/5 x plus 2 over the domain of -10, 0, and 5. I've made my table of values with the -10, 0, and 5, and I've made my substitutions in each one of these functions. When x equals -10, y equals -4. When x equals 0, y equals 2. And when x equals 5, y equals 5. Therefore, my range is the y values, which is -4, 2, and 5. Moving on to number 11. Here we are given y equals 7 minus 1/2 x over the domain of -4, 0, and 6. So I create my table of values with those x values, -4, 0, and 6, and I substitute those x values for x and evaluate this function. And I find that when x equals -4, y equals 9. When x equals 0, y equals 7. And when x equals 6, y equals 4. So my range is the values of y, which are 4, 7, and 9. And if you want some extra practice, you can go ahead and graph these. So number 12, we have the function y equals -2/3 x plus 9. You see that I have used parentheses to make all my substitutions, and I'm substituting the values -12, -6, and 3 and I've created my table of values. So when x equals negative 12, y equals 17. When x equals negative 6, y equals 13. And when x equals 3, y equals 7. So my range over this particular domain is 7, 13, 17. Box this answer as well. Be careful here so I don't cover up the other problem. Right, number 13. We are given the domain y equals 7 minus 4x, or given the function y equals 7 minus 4x over the domain negative 3, negative 1, and 5. So we've made our substitutions in this function, and we have found that when x equals negative 3, y equals 19. When x equals negative 1, y equals 11, and when x equals 5, y equals negative 13. From least to greatest, the range of this function is negative 13, 11, 19. And our final problem of the day, we are given y equals 1/4 x minus 5 over the domain negative 8, negative 4, 12. So let's evaluate by substituting these x values into our function y equals 1/4 x minus 5. And when x equals negative 8, y equals negative 7. When x equals negative 4, y equals negative 6, and when x equals 12, y equals 2, for a domain of negative 7, negative 6, and negative 2. So finally, we're on to our graphic organizer. And our graphic organizer is all about ways to represent relations. And we can represent relations as ordered pairs, tables, mapping diagrams, equations, and graphs. So let's take a look at these 5 ways to represent relations. So when we have our ordered pairs, we look at the domain, which are the x values. So the domain is the set of all numbers that includes, do neater than that, that includes negative 1, 0, and 2. The range are the y values, and that includes 2, 5, and 7. Is this a function? Does each domain have its own range value? Yeah, I don't have any repeats in the domain. So yes, it is a function. Now we have up here a table of values, and the domain, again, are the x values. So the domain is, and we'll go in order from least to greatest, and we do not repeat numbers when we do this. So we have negative 2, 0, and 3, and our range is starting from least to greatest, negative 4, 1, 2, and 6. Is this a function? Well, look what we have. We have repeated domain. So this is not a function, okay? When we have these repeats in the domain, if a domain gives 2 different outputs, here it gave a 1, here it gives a 6, that's not a function. That relation would not pass the vertical line test if we were to map it, to graph it, excuse me. So, okay, so let's look at the mappings. We have a domain of negative 7, 0, and 3. Over a range of 1 and 2. Be careful. Does each domain produce one specific range or y value? Does each x value produce one specific y value? And the answer is yes. If I input a -7, I will always get a 2. If I input 0, I will always get a 2. If I input 3, I will always get a 1. As long as I have individual unrepeated domain values, yes, this is a function. Now, we're going to look at the graphical representation of a relation. And if we, I'm going to kind of trace it a little bit. And the domain are all the x values. So the domain is from here to here. I don't know if you can see I hope you can see what I did. The domain includes everything from, -4, okay, so here's my -4, to +1. So -4 is less than or equal to x, and x is less than or equal to 1. That's the domain. Now, the range. This is the range. Everything from here to here. So the range are the y values, and this is -2, and this is +3. So -2 is less than or equal to y, and y is less than or equal to +3. Now, is this a function? Is this relation going to pass the vertical line test? And the answer is no. It passes through at 2 points, so it is not a function. And finally, we can represent relations as equations. And when we have y equals x squared minus 1, if we were to graph this, and let's say we made a table of values, and we substituted some x values. So if we substituted -2, -1, 0, 1, and 2. So we would have -2 squared, that would be 4. -1, oh, I'm sorry, I forgot to do my -1. Okay, so let me actually draw it out for you. Y equals -2 squared minus 1. -2 times -2 is 4, minus 1 is 3. Okay, now if we substituted -1 times -1 is +1, minus 1 is 0. If we substituted 0, we would have -1. And if we substituted 1, we would have 0. And we substituted 2, we would have 3. And if you were to graph these values, so let's say we turned them into ordered pairs, okay, put parentheses around them, and turned them into ordered pairs, you would see that this function would pass the vertical line test, but you would also see that the domain is all real numbers, but the range would be, this is our clue right here, okay? So our range would be y is greater than or equal to -1. And as I said, this would pass the vertical line test, so this would be a function. This is something we haven't talked a whole lot about yet, but we will talk about that in the next coming weeks, so you can look forward to that. So thank you for paying attention to our lesson on equations as functions. It takes practice, Make sure you always use parentheses when you make your substitutions. That'll keep you out of a lot of trouble. So you've done a great job today. I'm proud of you. Keep up the hard work, and with practice and homework, you'll be great.